so now that we looked at deep learning frameworks, let's talk a little bit about project management. So managing projects, and here I mean deep learning projects, but this also applies to machine learning projects. So you're going to see this week we're going to be using a lot of Colab and Jupyter notebooks. And while these are great tools for quickly iterating, they're not necessarily the best tools for scaling and deploying large projects. You'll see very quickly why once you start using it. We can talk about it offline for a long time about why it might not be a good idea to be using Jupyter notebooks in production. But the idea is that things can get cluttered very quickly and disorganized very quickly. And so I want to give you now a bunch of different tips for how to manage a project, particularly a deep learning and machine learning project. So the first point I want to talk about is maintaining an organized code base. This is really important. When you're working on code, you're going to be working on code with other people. You want it to be relatively easily for someone else to come in on this project and be able to find themselves. So here's an example of a tree structure that usually comes around a lot. You might have a folder with models, a folder with data, a folder with results that you can ignore, a utilities folder. You want your code to be organized in a hierarchical structure. You want it to be easy to find different modules, different functions, etc. You also want to use logical names for variables, file names, folders. Like, avoid using variable names that don't make any sense, especially in your code, right? Again, Python is built around the idea that readability counts. So if you're using a variable, say, to tune the learning rate of your model, just call that variable learning rate, right? Don't call that variable A, or something that has nothing to do with the learning rate, such that when someone is using your code, he can actually interpret that variable to mean what it actually means. Another really important point is to avoid code duplication. And that's one of the reasons why I think Jupyter notebooks can sometimes be a bad idea, is that it's really easy to duplicate code in Jupyter notebooks, mainly because it's quicker sometimes to duplicate your code. But then you'll find that if you find a bug, say, in a training routine, all of a sudden you have to go change it 10 times instead of the one time where you found that bug. And it could be really easy to forget about one time where you mentioned that coding routine, that training and data loading routine, and all of a sudden you have a bug in your code and you didn't pay attention. So if you modularize your code, wrap everything in functions, and avoid code duplication, you're going to avoid that from happening. Another thing is that Python is an object-oriented programming language. So we're not going to go in too much to the details of what object-oriented programming is, but I recommend that you go online and read up more about it if you're not too familiar with it, and use those paradigms. Python was really built around that, so just use it to its full potential. I would recommend also following PEP guidelines. So PEP, they are Python enhancement protocols. So these are suggestions that the Python creators and moderators give to the public, and it usually says how to and how not to do things with Python code in general. So this could be how to lint your code, how to have code be more Pythonic. So in Python, you can have code written in many different ways, and the code will still run, but then there are things like, did you put too many white spaces in your code? Did you put too many spaces before the last comma? Is your line too long? Right? There are these certain rules that you can adhere to, and it makes everyone happy when everyone follows these rules. Because again, if you're writing your own code, that's, I guess, okay. But the second someone else comes and looks at your messy code, it just makes them really unhappy. And finally, document your code. I remember hearing once someone saying how, only other people write bad code. Right, just remember this. You always think that someone else's code is bad, and you always think that your code is the best. But really, we all have our own writing styles, and it's because you can inherently understand what you've done because your brain came up with it. When you read someone else's code, you're reading their way of thinking, and it might not be intuitive to you. So that's where it's really important to document your code, and it's also important for future you. Whenever you read back code from a few years ago, your programming style might have evolved. You might be thinking, well, what was I even thinking with this design decision? Well, you have documentation to go back to it and refer to that. So another thing I want to talk about is version control. So again, let's do a raise of hands. Let's make sure everyone's not asleep. Who here has heard of Git? Okay, lots of hands. Who here uses Git regularly? Okay, still good. So we're going to talk about versioning your code with Git. So for those of you who don't know, version control systems, Git is a version control system, and this is a tool that allows you to keep track of all the changes that happen in your project. So why do we need this, and what does that mean? Maybe you've already found yourself in this situation where you have some project where you're not using GitHub, you're collaborating, maybe it was a Dropbox folder, and all of a sudden you get these duplications where you have experiment 1, and then you're afraid that you might lose something, so you do a change, but then you wanted to save the old version just in case you wanted to revert back to it, so now you have experiment 1 old. Then I come along and do an experiment 2, but someone improves it, and then there's the Jeremy version, but the not Jeremy version because we're collaborating. And it quickly explodes and quickly grows out of hand. This is exactly what Git in general allows you to avoid. Here are some popular hostings for Git. So you have GitHub, GitLab. And the way that it works is it has a branching paradigm. So essentially, everyone has their own copy of code. It lives locally, and you all agree with a kind of remote server that contains the truth to your project. And usually there is a person involved which can then decide if the code that you wrote can go into everyone else's code base. And the way that it's designed in a way that it's almost impossible to lose any kind of code that you've written. As long as you use the tool properly, there's almost nothing that can ever go wrong, and the code is distributed among all your peers. So it's really, really hard to mess something up. And again, you have this concept of branches. So you might work on a project together. I'll start at this point, and then one person goes along and writes maybe a patch of code, submits it, someone can review it, agree on it, and GitHub or Git in general manages all of this for you. So if you get to the point in a project, say you're somewhere along on this time axis, maybe you're somewhere here in your project, this entire history lives with the project. Every time you get a copy of the project, you also get a copy of all the changes that have ever been made to this code. And you also get all the authors that have ever participated. So this is very useful, for example, if you have a code base and all of a sudden something breaks, and it's one line in particular, and you think, who wrote this line? There's a function called git blame, and you type it, and it tells you exactly who wrote that line. And it's even funnier when you're cursing at that person, but then it turns out it was you who wrote that line. So again, Git is a very, very powerful tool, and I really recommend you start using it if you don't already. And once you start using it, you'll wonder how you ever lived without it. So the next point we're going to get to is virtual environments. All right, we'll do the hand thing again. This is fun. Who uses virtual environments? OK, we still have a good amount of hands. So virtual environments are a really useful feature, mainly because like we've seen up until now, Python is a rich ecosystem of libraries, and so you have many, many different libraries all over the place. And these are third-party libraries, so there's no one really regulating how these libraries get updated. And usually these are volunteers who are volunteering their own time to these libraries and making changes to these libraries based on what they think is best. So it can happen from one version to the next that code that worked with one version of the library all of a sudden breaks on a new library. Maybe the order of how you were putting the inputs has changed. Maybe something has changed completely, and all of a sudden, a project that you were working on 3 years ago is no longer compatible with the newest version of the library today. So virtual environments allow you to kind of avoid this as much as possible, and what they do is they isolate every project with its own set of versions of each library. So if you want to update a library, you update it for a particular project. Another project that you worked on years ago, that library stays frozen in time. And you even have a recipe how you can get back exactly to the state of that project when it was running successfully. So if you deploy something in production, for example, you can always make sure that the versions of your library are exactly where they need to be. This is very, very useful and will save you a lot of time. There's nothing worse than having to downgrade libraries and then break another project because you were trying to make one project work, and all of a sudden things start breaking all over the place. I recommend Conda. There are different tools. Conda is probably one of the easier ones to get started with, and it allows you to manage these libraries, and you can use pip alongside Conda. We're not going to go deep down into what the difference between Conda and pip is, but Conda is really a virtual environment manager, and you also have some different alternatives like virtualenv, pipenv, and again, different flavors for different people. Just use something to manage your virtual environments. Finally, the last point I want to talk about is using unit tests. So unit tests are really important, and it's always good practice to have unit tests. Unit tests are kind of like a seatbelt. You never really need a seatbelt until you need a seatbelt. You never really need unit tests until you need unit tests. Unit tests are there, you put them in place to make sure that when you push code up, it doesn't break the rest of your code. And again, you should come up with your own unit tests to make sure that they reflect your project. But the idea is that if you put up a set of well-defined unit tests, it will be very, very hard to push a change in production that'll make something catastrophic happen. Because there's always things that we don't necessarily think about when we're uploading code. And again, it could be as simple as just accidentally deleting a line in code. And that's something that can go under the radar when you're doing a code review. You push that to production, and all of a sudden, your project fails. So there are, in fact, ways to put up unit tests and to make it such that it's actually impossible to push code up without having all of the unit tests pass. So I really recommend adding unit tests to your code. And again, a bunch of different libraries out there to do unit tests with Python, and PyTest is one of them that I might recommend. So now let's talk about experiment management. So Gaetan mentioned earlier that you might have many different hyperparameters to an experiment and have different experiments that you want to run and different models that you want to test. This is because deep learning is inherently empirical. It's really difficult to know which parameters will have what effect on a model other than to try it out. And sometimes experiments could take days, hours, weeks, months. It really depends on the kind of models, but they could take a really long time to run. So what you want to do is avoid having to run multiple experiments over and over. And to do that, what you do is you usually organize your experiments, and you want to be able to log them in a structured way. So you have different tools to log and visualize experiments. So here we have an example of MLflow, which Gaetan spoke about briefly earlier. And what's really nice about MLflow is you could put all of the different parameters that you've used for a certain experiment, and when you go back in time and you look at your different metrics, you can say, oh, what was the model that performed best? What were the parameters that I was using when I ran that experiment 3 months ago? And you could even look at the version of the code that you were using. So it'll take a unique identifier, the SHA, of your Git branch. This is a small detail, but that allows you to know exactly what version of the code you were running when you ran that experiment. So again, this goes into the whole reproducibility concept that Gaetan was mentioning earlier. If you want to reproduce your experiments later on without having to rerun these costly experiments. Another tool here that we see is TensorBoard. So TensorBoard is also useful in that it allows you to visualize your experiments dynamically. So as you're launching a model, you can see these different learning curves, and you have different metrics. So you can have accuracy, but also loss, and all sorts of different metrics that you might find useful, and you can visualize them in real time. So this is also handy because you might have 4 experiments where the loss follows a certain trend, and all of a sudden you changed something, you launch your experiment, and you see that your accuracy just never increases. So if your experiment takes weeks to run, but after, say, a few hours, you notice that your accuracy hasn't budged when it would actually move relatively quickly on other experiments, then you can decide to kill that experiment relatively quickly, and again, by just looking at it. Finally, you have some tools that allow you to do some hyperparameter optimization. So one of these tools is Orion, which was also developed at Mila. And it allows you to tweak some parameters in a kind of automated way. So we're going to look at, throughout this week, you're going to see the different parameters that might affect the network. But you'll have hyperparameters that you can tune that essentially, there's only one way to know if they work well or not is by trying it. And so you'll have these frameworks that allow you to do this hyperparameter optimization automatically. And what you do is you say, here's the search space that I would like to consider. Please find me the best parameters for my network. And so you give all your hyperparameters, and this hyperparameter optimizer has been built to find the best parameters by running as least experiments as it statistically should. So here, let's look at a list of different tools that allow you to do what I just spoke about. As you can see, there are a lot, different flavors for different people. One tool that I like lately is MLflow, mainly because it's open source, and it allows you to do a lot of these different things, including experiment monitoring and organizing. The one thing it doesn't allow you to do is hyperparameter optimization, but again, our friends at Orion allow you to do that, and they can actually play nicely together. So you can go through this list later on. Again, different services will provide you with different advantages.